In this problem, we're looking at increasing the pressure on a binary vapor mixture. So we start out with a 50-50 mixture of components A and B, and then we increase the pressure and ask, what does a plot of the mole fraction of A in both the vapor phase and in the liquid phase look like as a function of pressure? So as we increase the pressure, eventually we form a liquid. The liquid and vapor are in equilibrium. We keep increasing the pressure, we're going to have all liquid. What do these plots look like of how these mole fractions are changing if we have given that the saturation pressure of A is greater than the saturation pressure of B? Well, the best way to look at this problem is to look at a PXY diagram. So here's a PXY diagram where the saturation pressure of A is higher than the saturation pressure of B. Because it's an ideal solution, this is a straight line. High pressure is liquid, low pressure vapor, and this, of course, is vapor-liquid equilibrium region. The problem says we start at 0.5 in the vapor phase, and we're going to increase the pressure. So as we increase the pressure, the mole fraction in the vapor phase doesn't change till we get to this point where we get the first drop of liquid. This is the dew point. And so let's plot the mole fraction as a function of pressure. Well, as the pressure increases, the mole fraction of Y, the vapor phase composition, doesn't change until we get to this point. And here we see the mole fraction of the liquid that's in equilibrium, right? This line is pressure versus XA. The mole fraction of the liquid is much lower, so let's put it arbitrarily at this value. So this is Y of A. I'm going to plot down here X of A. X of A is not defined here. And then as we continue to increase the pressure, for example, we get to this pressure, this is the X of A here, that's in equilibrium with this Y of A. So you can see both X of A and Y of A increase. I'll draw them as straight lines just for convenience. And this will continue to happen until XA equals the original YA, 0.5. This is now the bubble point. And at this point, now as we continue to increase the pressure, try to increase the pressure, all the vapor is gone, and so we only have X of A here, and Y of A is not defined past this, and of course this value is 0.5 out here. So this looks like our original diagram B in terms of how the mole fractions change as a function of pressure.